Okay, so this next video, I'm going to show you a function that I basically use constantly, all the time. This is a function that honestly, when I show this to people who've just used spreadsheets in the past, it's often the primary reason that they decide to start learning Python and Pandas, because it's just so darn hard to do this in a spreadsheet. It doesn't make any sense. And the concept itself is, it's called resampling. That's the name of the function we're going to look at. Resampling is essentially when you have time series data at a certain frequency. Often you have really, let's say, high frequency data that's every 5 minutes or 2 minutes or 1 minute, and you just need daily data. You just need hourly data. You don't need that high frequency data. Well, how do you do that in a spreadsheet? Well, yeah, there are ways of doing it, but in Python and Pandas, it's really fast and easy, and it could change your opinion on whether if you're on the fence about learning Python and Pandas. This is probably the function that's going to cause you to change your mind. So we're going to load that file that we just created, that time series data, so we don't have to query. This is a situation where, if we pick this up later and we don't want to query that database again, we could just load that CSV file. So this is kind of a practice that I do a lot. I mean, it depends on your style. You might, always want to query APIs, get the best data, the most updated data. But this is a static data set, so there is no updated data in a sense. So flat files, it's sort of like snapshots or something that's nice to have. So yeah, we have 19,000 rows in this time series. There's 168 different entries. One of the things we need to do right away is we need to create a timestamp column from we already have a timestamp column. We need to convert that timestamp column to a date time. That allows us to use that as the column for the index, which allows us to then do things like resample, which we'll talk about here in a second. So here we go. It shows our timestamp as one of the columns. Right now we're not going to make this into the next index. We're just going to use that column timestamp to do the resampling for this. So you'll notice that, the first 10 rows of this, a lot of these rows initially are NaN, so these are blank data. But the thing we want to look at here is the fact that the timestamp itself is, this is 2:15 p.m., this is 2:30 p.m., 2:45 p.m., 3 p.m., right? So 15-minute data, right? So this is the type of data that is high enough frequency that you can really find some really detailed, let's say, behavior, but sometimes you don't need 15-minute data. In the text here it says it's 15-second data. In fact, it's 15-minute data. So here's where we use the really handy resample function. And resample is really just .resample. And then you have in parentheses, there we go. In parentheses, you have this character D. What does D mean? It means that we want to change it from 15-minute data to daily data, 24-hour data. And we're going to do that on the column timestamp. If the timestamp was actually the index, then we wouldn't need to do this. It would just be default. And then we have to have an aggregation function, .mean. And what's that for? Well, it's whenever you take, let's say, 15-minute data, convert it to daily data, how do you aggregate across those windows that you're changing? Mean makes sense. Let's say if you're doing temperature, because you just want to find the average or mean across that day. If you were looking at energy consumption, kilowatt hours, you would probably want to use .sum, right? Because you want to find the accumulation of energy across the day, not just the average daily, unless that's exactly what you want. So here, if we run this line of code, what's going to happen, you see, is your timestamp converts into a daily timestamp. So instead of every 15 minutes, you have here January 20th, January 21st, January 22nd. And because, there's 365 rows instead of 19,000 something rows, you have 365 rows. So this is a great way to smooth the data, to reduce this file size, to really remove a lot of the detail that you don't really need. Hourly, that's another timestamp which is really common you want. So 15-minute data to hourly. I actually convert a lot of my higher frequency data to hourly before I store it, just because I think hourly for a lot of cases is good enough in a sense, if you're looking at, let's say, energy meters. So here you can see with hourly data, you have 2 p.m., 3 p.m., 4 p.m., And some of this data does have, it does have some data here that we can see, and it's taking the mean across that data. So let's dive now into, now that we've figured out how to resample, let's look at plotting. So that's, of course, we're going to, like I mentioned in the last set of videos, exploratory data analysis is really one of the first things you want to do. So it's probably the thing that you're working on right now. So we're going to bring back our Seaborn library. We're going to set some parameters for Seaborn. So if we run that chunk of code, we can, let's plot the raw data from our sensors. So let's get the column names that we have here. And let's create a line plot for each of these columns. So we have 167 of these time series. These are zone temperature sensors from fan coil units. If we run this chunk of code here, so what you end up with is a line chart with all of these points together on the same chart. And I cut out the part where we waited for it to actually execute. It might take 10, 20, 30 seconds, depending on how much data you're trying to plot. Here we're plotting 167 points across a year, so it took a little bit of time. But if you plot less than this, it takes less time. If you plot more, it takes more time. So please be patient, or if you want to plot huge amounts of data, we'll show you how to use the heat map here in a second, which is a lot faster for large amounts of data. So let's look at this data here. We have this kind of big, huge gap here. Looks like from about March until September, we have a big gap of data. That's really common in time series data. You can see before March and early 2017, there's a few points here, whereas in September, you gain a few points, it looks like. And then towards the end of, let's say, the year, December, January, you've got, looks like most of your 167 points are actually popping up here. And you've got a lot of points that are, zone temperatures that are pretty cold here. Okay, so this is and this is Fahrenheit. Sorry, I had to switch my brain from Celsius to Fahrenheit. So we got some zone temperatures getting down to 20 degrees Fahrenheit. That's kind of interesting. We've got this big gap of data. Let's just look at some of that data. So let's filter all the data out after this 1st of September, just to zoom in on that. You could use a function called Truncate as well. So there's different ways to slice data. Here we're just going to filter according to one of the columns. And then we can look at that timestamp here. We can see, after September 1st, we have sliced the data. But like I said, Truncate is another way of doing that. These are some other ways that you can analyze time series data here. So you can get the timestamp. You can use functions within the timestamp like .dt.date to get the actual day of the date itself. And then you can also use in the timestamp a function called .weekday to figure out if it's a weekday or not. So Monday is equal to 0, Sunday is equal to 6. So when you look, you can look at the timestamp according to the weekdays. So you can filter according to days of the week. So before, if you just want weekdays, you could say slice off the 5 and 6, which is Saturday and Sunday, and only look at Monday through Friday, perhaps. You can use the timestamp or .hour to get the hour of the day. Let's say you only want to filter out all the early morning hours. You can actually use this as a parameter to filter according to hour. You can get minutes. So look, like I said, we have 15-minute data. So here, if you get that, you can see the 15-minute data. Let's convert this to hourly data because 15-minute data is pretty high frequency. So let's go ahead and create a new data frame called data_hour. Here we used 1H for hour. You can also just use H is fine. But if you wanted to resample according to like every 3 hours, you could do 3H, for example. Let's plot the hourly data for this zoomed in data set. So here we have our hourly data set. Once again, you've got, like I said, this chunk of data here in December, January, which is quite a bit of data. You've got some of the data here from September until December. A few points, looks like 3 or 4 points. It's a little bit easier to see the detail here because we've zoomed in a little bit. We've smoothed the data set by having it be hourly data. We can further smooth the data set by resampling to daily, or in this case, we put 24 hours. It's another way of resampling in that way. And if we plot that, it's going to be much faster than the other ways, using much more high frequency data. Here you can see the data is very much smoothed out. It took a lot less time because there's like hundreds of points instead of tens of thousands or thousands of points. Here you can see there's still quite a bit of jumble there for looking at these individual points here towards the end of December, early January. So the line chart, I mean, this is a line chart, which a lot of people love to use, but sometimes, of course, when you have this many points, it's very hard to see everything. So in the next video, we're going to talk about heat maps, which is one of my favorite ways of visualizing time series data.